Okay, let's talk about multiplying and dividing with algebraic fractions. This is a whole lot easier than when we were doing adding and subtracting with algebraic fractions, that's for sure. Once again, it's a nice long title, so it's a bit down the screen. Let me move this all up. Okay, so here is my algebraic expression with some fractions in it. I've got 5y over 3x multiplied by 6f over 7y. Now it's really important in the very first step here to look for opportunities to do some cancelling out of numerators with denominators. For example, this y here will divide into this y here. This 3 can be divided by 3 to leave 1, and this 6 can be divided by 3 to leave 2. So when I come to my next part here, I'm going to end up with a very easy expression to finish. So and you'll notice that it makes my multiplication and keeps my numbers pretty small. I've got 5 multiplied by 2f, which will give me 10f, and I have x multiplied by 7, which will give me 7x. Now that's not to say that I couldn't have done it without doing this cancelling in this first instance. It just makes it a lot easier if I do. Here is, in blue, what would have happened if I had multiplied out this top expression without doing any of that dividing or any of that cancelling out. I would have ended up with 30fy over 21xy, and I would then have to bring it to its lowest terms, and I know I would divide that y, and I would divide that by 3, and I would divide that by 3, and I would end up with exactly the same answer, but my numbers in this instance are more difficult to work with. They're bigger and busier. Okay, so my hint is to look for opportunities to cancel things out as you start. Let's do another example. Here I have a nastier looking algebraic fraction, but once again the process is the same. First step, we look for opportunities to cancel out denominators with numerators, things that we can shift, makes it easier for us to work. Here I have an x, which will leave a 1, and here I can cancel that, it'll leave a times 1. This x plus 1, this binomial factor here, will actually cancel out with this x plus 1 and leave a 1 there and a 1 out here. So when I actually come to do the multiplication, there's not really any real work to do. I've got 2 times 1 on the top, and I've got 2x minus 3 times 1 on the bottom. And because we know that identity law, we know that anything multiplied by 1 retains its identity, and our answer was done easily with just some cancelling out. If we'd actually multiplied out that stuff, that would have been a whole lot messier, that's for sure. Okay, always look for those opportunities to cancel out. Let's have a look and a talk about division as it relates to these algebraic fractions. Here I've got 3xy over 2 divided by 4x over 9y. Now it's important to remember that division is the reciprocal operator to multiplication. So if we're doing multiplication with a fraction, you multiply by the numerator and divide by the denominator. Well, the division sign means you do things in the opposite order. It's the reverse. It's the reciprocal. So what we're going to end up doing here is actually multiplying by the reciprocal. I take my denominator and it becomes the numerator. I take my numerator, it becomes the denominator, and I need to change my operator. I need to change that sign in the middle. Now, to talk about really what's going on here, I got a call. I'm just going to ignore that for now. I'll turn off that sound. I'll get back to that in a minute. I then want to talk to you just really quickly to really show you what's going on with that. Here, very simply, if you can do the simple ones, you can do the trickier ones. So let's think about what's going on here. If I've got 6 being multiplied by 1 over 2, well, I would do 6 times 1, well, that would be 6, and then I would divide it by 2, and that will give me my answer of 3. So if I know that division is the reciprocal function of multiplication, then I would do 6 divided by 1 multiplied by 2, and it should give me 12. Well, let's have a look. I said that if we multiply by the reciprocal, so I've taken my 1/2 here and I've flipped it upside down and put a multiply on it, do we get the same answer? Well, 6 times 2 is 12, divided by 1 is 12. And it does, it works, and it works for every fraction that you're dividing by. Okay, let's get back to this one. Once we have it in this form here, well, it's just it's the same as our multiplication that we were doing before. I can look for opportunities to cancel. I can cancel that x there, that x there. That really looks like all I can kind of do. So the next line will look like this. It'll be 3y over 2 multiplied by 9y over 4, and my result, I would multiply 3y by 9y, and I would get 27y squared, and 2 times 4 will be 8. So there's my answer. We'll do that one last time so that you can see the process involved. Even with the really trickier ones, the trickier looking ones, it still works. So here's my expression. I'm not even going to read that out. I'll let you just look at that for yourself. I'm going to rewrite it, but I'm going to express this part, the dividing part, as a multiplication by the reciprocal fraction, which I have done right there. I'm once again then, once I've rewritten it, going to look for opportunities to divide between the numerators and the denominators to cancel things out. And I'm going to cancel that out with that one there. I'm going to leave a 1 up here and a 1 there. The next section, I'm then going to look at it and see what I've got going on and multiply it out. So numerators, 4 times 1 will just be 4. And I'm going to need a little bit of room to show. And the final one, I'm going to have 3x minus 5 multiplied by x minus 7. And remember, we generally will tend to leave factors like that, these binomial factors, instead of multiplying that all out, unless you're asked to. Okay, so that's multiplying and dividing with our algebraic fractions.